when I started this kind of the topic, probably the most important thing initially was this probability equation, like number of possible outcomes on the bottom, number of favorable outcomes on the top. That's the fundamental probability calculation. So that was almost like lessons 1 and 2. Then we also did the Venn diagram up here. And we also talked about the addition rule identity, which is this one over here. We also have that we talked about mutually exclusive events. And then we also spoke a little bit about the complementary rule. Then we went along, and after doing the Venn diagram, we went along and did the tree diagram. And the tree diagram was much more closely related to this calculation, or the independent events type of calculation. And then in the last lesson, we started something called two-way tables or contingency tables. And the main thing we were doing is we were showing that this identity over here was true. And if we showed that was true, it allowed us to conclude that events were independent. Okay. However, all of these topics come up in the probability questions and exams. And so it's a good thing to be aware of that sort of the core material. Okay. Now, before we get going and continue what we were doing in the last lesson, are there any questions or comments about this overview of theory? Just give me a thumbs up if you're like, no, I've seen this before. Sure, I have to practice it, but I feel like I've seen most of this stuff. Oh. Oh. Turns out load shedding is here. Can you guys?
Oh, no.
It's fine. I'm here.
Don't panic, guys.
Hello. Are people with me?
Yes, yes, Mr. S.
Okay, awesome. So just give me, okay, I'm seeing lots of thumbs up. Fantastic. All right, well, let's go then to a question. And this was a question from an old exam paper. And I just want to give you a chance to try and do that. So go ahead and step 1, I want to know, first of all, how many students are there at the college? So this question is, it's comparing gender, or this table is comparing gender to HIV status. And there are a bunch of students that have been tested at a college. And I want to know how many students are there in this college based on the table. That's what I want to know. Yeah. So the total value, if we look at the table, we know the total number of people in this table is going to be hanging out down here. So that is going to be 960. All good. Okay, now I want you to work out these missing values using the idea of using one value to help you work out the next. I don't want to say too much because we did do this in the last lesson. I will say this much, that each row is a total, each column is a total. And so how can that help you find the values A, B, C, D, E? To pop those, or if you, yeah. So I see a lot of people who are saying that A is 86, which I am pretty convinced about. And that B is 528. And that makes a lot of sense to me as well. What about B and C? So in order to get C, it feels like I have to use the 960. So I get C of 4, 3, 2. Yeah, that makes sense to me. What about D and E now? So for me, how did I get D is 4? I would go 432 minus 86. So 432 minus 86, 346. And then for E, we should get 768. Oh, what a pleasure. 1 mark for the first one, 5 marks, 6 marks in the bag, moving swiftly along. Okay, now we have to talk about independence. And I want to know from you, in fact, I feel like you should. So, okay, let's look at the question. It says, is being HIV positive independent of being male? And it says round to 2 decimal places. So this is actually quite important. I didn't mention this in the last lesson, but at some point you have to have a degree of rounding for these independence calculations. And so we're going to use 2 decimal places. But what I want to know from the class is, what are the 3 pieces of information I have to calculate? I'd love someone to put their hands up and tell me, or what are the 3 key pieces of information I need in order to work out whether or not these are. Can we unmute Lesego?
Yes.
The 3 key pieces of information that you need is the probability of someone being male, the probability of them being HIV positive, and the probability of those 2 things happening at the same time.
Which word would we use?
You're
right. You're absolutely
HIV
right.
positive and male, or HNN.
Yeah. So what I want is, I want everyone, that's perfect, Lesego, thank you so much. What I want is, I want everyone to work out those 3 probabilities, and then I want you to make a conclusion about whether you think these are independent or not. But I'm going to give you some time to do that, because I want you to write it out. It's worth 4 marks. But those 3 pieces of information are indeed important. So those are the big 3 that we need to know. Aha, sorry guys, I'll move the table up now. It's I'm on my laptop instead of my lovely big monitor, so I have to adjust. Okay, so Dawn, what I would say is, start by getting the 3 pieces of information, and then you're right, you do have to decide whether or not the check for independence is to, you have to check whether these 2 multiplied together is the same as the and 1. But first of all, you need to actually get these 3 values. So first of all, what's the probability of being male in this set? Now, you need to know how many people there are to start with. The good news is you found that out already. It's 960. So what, but I'll wait a little bit before I give the game away. I feel like I deserve a stretch early in the lesson. So we know, it feels to me like this is the probability of being male should be 5 to 8 over 960. So that's the hint I'm going to give you. Okay, so I see Mason has an HIV positive probability there, and it's definitely going to be over 960. Now, HIV positive, it's going to have to be this 192. So that's that probability. And Royalty agrees. And I agree that those are the correct ones. Now we still have to find the third one, and then we have to do some calculating. And remember, the question said to 2 decimal places. So let's have a quick. So for male and HIV positive, this is going to be the 106 is the important number. And I agree with Anya and Anyo and Dawn that it's going to be 106 over 960. So we have to, once we've got those 3 values, we're almost there. We have to do a calculation now where we check what the probability of being male times the probability of being HIV positive is. So, and we need to conclude whether or not it's equal to the other side here. So let's see what we get on our calculators. Now, 2 decimal places is our degree of 528 times. So I get 0.11 for this one. And I also get for 106 divided by 190. Great. Have I done this right? 106 divided by 960 is 0.11 as well. So 0.11. So what we have found is we have found that this times this is equal to this. Now, what does that mean? What can we conclude? So if this times this is equal to this, therefore they are independent. Dependent. So when the equality holds, when they're equal, they are independent. When it's not equal, they're not independent. In this case, because they're both 0.11 or 0.11, they are independent. Okay, so it is possible. So in this case, what that's saying is whether or not you're male or female doesn't affect your chances of being HIV positive or negative, right? So the data is saying it's basically, in this case, they're independent. Gender and status are independent of each other. The one doesn't give you any information about the other. Okay. Give me a thumbs up if you're feeling okay with this. Thumbs down if you feeling a bit lost. I would imagine for someone who's first lesson, you might feel like we're going a little bit quickly, but remember the recording of the first lesson is available as well. Okay, now let's move on to a second question. So here is your second question, and you guys are going to fly solo on this question. Well, let's do it in pieces. Let's first say, what is the value of, do 10.1, and let's just check we all got the right answers. So 10.1, and then we'll go from there. And then, just to remind those students who perhaps maybe do have some questions, I'm assuming that today is more about practice from the first lesson, but there may be questions in the class. If there are, please do raise your hand or put them in the chat, and I'll do my best to give you a little explanation while other students are working. That's 140. And then this is going to be 80. What's going to be 290. And this is going to be 285. Cool. So that is 4 marks for basically filling out the missing information in the table. And the biggest thing is that students, when they see this in the exam, it's a bit overwhelming in terms of the detail. But if you've done enough of these are lovely questions. Okay, so 10.1 is done. Now I want you to try and give me the answer for 10.2. And again, I think it's better if you try by yourself for now. Okay, I see Loretta has locked in her answer. Who else has an answer? Mason has an answer. So I know that this is going to be an important number because that's the total number of students. And so the person is female, excuse me, and has not broken her arm. So where is that? So female is that row, did not break an arm. It feels like that would be the important one. And the answer I'm seeing in the chat is 145 divided by 575. If they want to do decimal places, that's fine. But here they haven't said anything. So, okay, 10.3. So I want to know, what about 10.3? Can you answer 10.3? So with 10.3, we have to be careful because there's a little bit of sneakiness that's woven in here. Given that a male shopper is questioned, that is a condition. Given that a male shopper is questioned, I want to ask you, how many males are there in this survey? So let's ask, how many males are there in the survey? Pop that in the chat. Where would I go and look for that? The number of males in the survey. So for me, that's a total of 350. So when I play the game here and calculating probability, I've only got 350 possible options. So that's a little bit different type of question. So be aware how the wording changes it. So if I know that I'm surveying the male population or the male survey group, what is the probability the person I choose will have a broken arm? Okay, so I've got to now go and look in the male row, which is here. What is the probability that they broke, or what is the number? So these guys broke their arms. So it should be that. $210 out of 350. Okay, so they can spice up the questions a little bit with some cool wording, but nothing crazy difficult, especially if you've looked at a few old papers. Now on to 10.4. I want you to try and tell me, I want you to think of the whole argument. So your focus is determine using appropriate calculations whether breaking an arm and being male are independent events. So that's what I want to know from you. Are they independent events? I leave the calculation to you. So the question has come from Bocanio, and I see Wandile has helped us out there. So basically, the 350 comes from the fact that there are only 350 male people in the survey, and that's this 350 here. So the column that's highlighted here, the yellow column is male 350. And because the question said, given a male shopper is questioned, we have to think of it as being out of 350. Okay.
Mr.
So,
Ace?
yeah.
Oh, I think you saw the question that I was.
Okay. So I was going to say, we use 2 decimal places unless there's other guidance. Generally, that's the guidance that's given on the exam paper. But so in this case, for the independence calculation, we'll use 2 decimal places. Yeah. Sweet. So the question, now we want to know, what calculations are? Oh. So I guess I need to get that one. And then I need to get that one. And I also need to know the possibility of doing both of those, the probability of being male and having a broken arm. So let me zoom in a little bit so I can see all the numbers. So the probability of being male is 350 over 575. Broken arm is 290 over 575, because that's the column here. And the probability of being male and having a broken arm is still going to be out of 575. But this is going to be the 210 over here. So in order to make my conclusion, I need to basically multiply this one by this one and see if it's equal to this one over here. So I get, well, in fact, you know what? I'm going to use the answers below because to save time, this is the final answer. So they are not independent. Okay. Just give me a thumbs up if you're feeling good. Thumbs down if you're feeling a bit lost. Just want to do a quick reality check. Okay, things are looking good. That is awesome. Okay, so what we're going to do now is, I think we've pretty much mastered this type of question. It's time to move on to a different but related question. But before we do that, we need to stand up and stretch. So please pop your cameras on and join me in stretching out. And Lebo, if you can please encourage our favorite students to stretch themselves out. I see that, Lebo, are you in the dark, or is load shedding striking, or what is?
No, I just have really bad lighting.
No, that's fine.
I'm still trying to get that light bulb.
No, that's fine. Not a problem. I was just like, what? Is ESCOM everywhere? Okay.
Oh,
No, all good.
Please join us in the stretch, guys.
Oh.
Give your body a break. Give your mind a break.
Oh, that feels good. Yeah. Touch your toes.
Oh, yeah.
Oh.
Your body will thank you.
Some of your stomach muscles. Oh, there we go. I found a stomach muscle. That's good. I thought I lost.
Ready for the second half.
Yeah.
Shout out to Lesego, shout out to Nadi, shout out to Nell.
Okay. Oh, that feels good. Stretch it out. Stretch it out.
For those who are camera shy, I hope you stretched.
Madumecha, do you want to ask a question? Go ahead and ask your question.
Good evening. I'm failing to see how you got to 10, like question 10.3. Probability of a broken male.
So the 210. Is that where I lost you? So
yes.
So the 210 is the being both male and having a broken arm. So if you look at the table, you'll see that all the male people who are being surveyed are in this row. However, there are some that broke their arm and some that didn't break their arm. And I'm interested in knowing the group of people who are both male and have had a broken arm. And so that's why I have to go to this bit over here. Oh, get that. Over here. Does that make sense?
Yes.
And so the grand total was 575. And so that's how together they 210 over 575.
So basically, when given a condition, I have to use the total of that condition, and only if it's random, that's when I use the total.
Yeah, so if it's a random, because random is like you're basically choosing from the whole set. Whereas if they said only male shoppers were questioned, then it's restricting it to just the male group, which was a smaller group.
Okay, thank you.
Pleasure. Okay, time for a brain break. How many days are there in 4 years? That is the challenge for today. How many days are there in 4 years? That is the question. Think about it. Think about how many days are there in 4 years? Couple of different answers coming in. Couple of different. Who would like to tell us their answer? Who's feeling confident? I'd love an audio. Who's feeling like they're like, I've got this. It's my time. Even if you get it wrong, it's not a problem. Yeah, but it's your time to shine. Kamo-san, let's go to you. What do you think it is?
It's 1,460.
1,460. How did you get that?
I added all the 365 days.
Yeah.
And I multiplied it by 4.
Okay, awesome. So I totally agree with almost everything. There's this one little trick, one little thing. So you're perfect except for one little thing. Does anybody else have what that one little thing is? Who has an idea? Who would like to raise their hand?
I have a hand from Katlego.
Katlego, let's unmute you. What's the extra bit that we have to add in?
Hi, Mr. S.
Hello.
Since 4 years is like what you call has a leap year, we have to add that one extra day from February.
Yes. Do you know which day we add?
The 29th of February.
Perfect. Exactly. Every 4 years, we add an extra day to the calendar for the leap year. And so it's February 29. So the answer will be 1,461, 365 times 4. Or you could have said 365.25 times 4. You get the same answer. Because it turns out that for the sun to go around the earth to go around the sun, let me make sure I get that right. It takes a bit more than 365 days. Did you guys give me a thumbs up if you know what a leap year is or if you've heard of a leap year? Just want to check. I'm sure you have, but it kind of sneaks in there. All right. Awesome. Okay, so let's go back to our questions, but let's change the type of question we ask. Little bit sneakier. So this is a old exam question where it's definitely got independence like flavoring, you know, there's definitely the word independent, but there's no table. And before we even asked if the events are independent, you're asked to calculate the probability of A and B after being given a whole bunch of information. So I was wondering, I don't want to kind of give everything away, but does anybody have any ideas as to, like, if we're not dealing with the table, normally we'd find the P of A and B from the table. What other information have you learned about in this section that maybe could help us find A and B? Now, you're given, this looks a bit new. So Loretta said she remembers something from a Venn diagram. Yeah, Leah Bonner, what do you think? I see your hand is up. What do you think might be helpful?
We are going to use the general rule, which is PA or B is equal to PA plus B minus PA and B. Then
You
we
are
will
on fire.
transpose the PA and B, and then the PA and B will be positive, and
Perfect.
then the PA or B will be negative.
You are smashing it. Thank you so much. So I want to give you this tip from Leah Bonner, that this identity, what we call the additive identity, could possibly be useful. And so I want to ask you, can you work out, using that tip, can you work out what the P of A and B is? Or the probability of A and B, which is this bit down here. See if you can work it out. I don't want to give away the steps, because if you make that leap by yourself, it's more likely to stick around in your brain. So how can we use this identity called the additive identity? So remember, we're not actually doing 9.1.2 yet. Eh? That's the second part of the question. First, I have to figure out what the probability of A and B is. Nadi is giving us a very good tip. So is Andile. You sub in the values. So you take P of A and you write, well, this would just be 0.2. So what is that going to allow us to get? So Neo, you wouldn't be able to say that yet, because they haven't told us the events are independent. If they say to you the events are independent, you can use that. But actually, they haven't said that. We're trying to prove they're independent. And to do that, we need to show that identity that you're talking about. But before we can even get there, I actually need to solve this problem. So A or B is 0.6. So now we ask ourselves, I suppose we could make this an X if we want, or we can ask ourselves, what do we have to subtract to get 0.7 to be 0.6? Both methods would be fine, but we need to figure out what that missing piece is. So what do we think it is? Yeah, so for me, based on that, I mean, I suppose I could do the algebra. So let's, if I bring the X across, I get this. And if I leave, that's 0.7 minus 0.6, 0.1. So we know that the probability of A and B is 0.1. Now we're going to ask ourselves, are the events independent? Now, you know the criteria for checking whether events are independent, right? The way you do it is you find the probability of the one, you find the probability of the other, you find the probability of whether it's A and B, and you compare them. And you say, are they equal or are they not equal? So I want you to do that calculation for me now and tell me, are the events independent or not? And then there's a question from Majumecha.
Will I be wrong when calculating the probability of A and B by using 0.2 times 0.5, which will also give me 0.1. Is it wrong, or do I have to do that whole process?
Yeah, no, so you have to, because you don't know. That was a lucky coincidence, to be honest. So you don't know that the events are independent yet. So you can't use the fact. It's like saying, like, you can't use something which you don't know in your argument. You have to use this general identity. So does that make sense? It's like you can't use it before you know it's true.
Okay, thank you.
Cool. So now what I do need to check is I need to see now, I want to prove they're independent. So let me clear some stuff out the way here. We know that this was 0.1, right? So that's what that was. The probability of A times the probability of B is equal to 0.2 times 0.5. So using my calculator, I get 1/10, or 0.1. The probability of A and B, we found earlier in the question, it was 0.1. So therefore, these guys are, this is equal to each other, and therefore A and B are independent. And that's it. Simple as that. When they're equal, they're independent. Are there any questions about that or comments? Yeah, so you can see it gets, the only thing that was a bit spicy about this was using this identity at the beginning. Okay, awesome. Nadi, that's awesome. It's just like everything in maths. If you have enough practice, if you have some guidance when you start and just continual practice, it does just kind of fit. Okay, well then, give me a thumbs up if you're feeling good, because I'm actually going to give you another question like this, if you're feeling good. Okay. Tell me about this question. I want you to try and answer this question. So you're given some information. However, I suppose you could try and answer this question first, but there's actually two questions in between. There's one about being independent, which I think you can figure out using the previous example. But there's also the question of being mutually exclusive. See if you can do that, or maybe maybe that we should ask the class, how would we show something's mutually exclusive? What are we looking to find? Anyo, yeah, let's go to you.
If you're looking to see if it's mutually exclusive, you're looking to see if there is an and, or if there isn't. Sorry, it's mutually exclusive if there isn't an and.
So basically, you're saying if this equals, one of the ways of saying it is if it's empty or if it's zero, if there's nothing in the intersection, they're mutually exclusive. That's what.
Yes.
Would you agree with that? Yeah, exactly. Yeah. Thank you, Anya. That's perfect. So what you need to do is, if you calculate what this is, now we don't know what it is, but if you find that out, if it's zero, it is mutually exclusive. If it's non-zero, then it's not mutually exclusive. So go ahead and work that out for me. So this is another identity which, yeah, if that's true, then we know A and B's events are mutually exclusive. Go ahead and do both for me, both A and B. I want to see if you can do both those. And to help you along, you're still going to use this identity. So A or B is P of A plus P of B minus P A and B. You have to use that identity because you're only given 3 of the 4 pieces of information. It's not possible for it to be negative. No, narrator, it's not. So let's start by people putting their answer for what they get for this value in the chat, because I think people are at many different levels. And I first want to know, can you work out what that is? And then from there, we can discuss whether or not something's mutually exclusive. So what do we have? We have 0.16 equals 4.5. I'm just going to call this X for the sake of making it easy. And then I'm going to move it across. What do I get on my calculator? So I get 0.585 for that. So what does that mean about being mutually exclusive? It can't be mutually exclusive. So we can say, therefore, A and B are not mutually exclusive. And the reason is, let me move something down because it's a bit too much. Because we have to provide a reason. The reason is because P of A and B does not equal 0. And so that would be my reasoning. Because if it was 0, they'd be mutually exclusive. If they're not 0, they can't be mutually exclusive. Give me a thumbs up if you're feeling okay about that. All right. Now let's move on to the independent stuff. So can you show me whether or not these two are independent or not? Whether these two events are independent? Let's move on to that calculation. Now, when we're checking to whether they're independent, remember what we're checking. And remember how you need to lay your argument out. I want to see the layout to be perfect. What are the 3 pieces of information I'm checking? What are the, what's the equivalence I'm checking, etc., etc. Okay, so we know P of A times P of B must give us 0.45 times 0.23, which is 0.135. We know that P of A and B, we worked it out earlier in the question, it was going to be 0.585. Now, what does that tell us? So basically, we know A and B are not independent. Sorry, guys, I'm really struggling to move the cursor around. So I'm just going to say they're not independent because these two are not equal to each other. So because this times this does not equal to that, so not equal, therefore they're not independent. Therefore they're not independent. And that's it. I like what I'm seeing, Figelo. I like what I'm seeing, Neo. And I feel like you guys are winning at life. Yeah. In fact, I think, should we do one more question, or do you think you guys are, do you think you've pretty much mastered this now? What do you reckon? Let's have a vote. One more question, or do you want to go to the quiz? Thumbs down if you want to go to the quiz, thumbs up if you can handle one more question. I love it. There's a bit of a mix. One more question. Okay.
Loving the enthusiasm.
Let's find a question that is suitable for okay, this is like a remix question, so we'll finish with this. Now what I want to point out is, well, maybe I shouldn't point it out. Maybe I should let you. So okay, so it says the following. Let's finish with this. For any two events A and B, it is given the following information. Then it says, determine what P of A and B is if that is true. I want you to try and answer that question for me. So you're given they are independent events, and you have to find the probability of A and B. See how I've given you something a little bit spicy just to finish off.
We can do this, guys.
It's all, the spiciness comes from the wording. Like, what are you allowed to assume? What are you not allowed to assume? The actual calculation is not too bad. So I see a couple of answers coming through in the chat. The key fact here is you're given they are independent. If they are independent, all that you need to do to find this is multiply, because you know that that equivalence holds, because they've told you they're independent. So you go this times this, and you should get 0.1248. Or if you round to 2 decimal places, 0.12. Okay, final question. Find P, A, or B if they are mutually exclusive events. So when you think of mutually exclusive events, you have to think about what we said earlier in the lesson, that if mutually exclusive events exist, P of A and B is 0. And so that can be quite helpful. In fact, the OR identity from earlier in the lesson can be used because the AND part is 0. So in order to find the P of A P, A or B, because the intersection is 0, it's mutually exclusive, that's 0. All I need to do to get A or B is simply add the A and add the B. in which case you are going to get 0.48 plus 0.26. And you should get 0.74. And that's it. Okay, so what I try to do at the second half of the lesson now was just show you some more of those sort of more abstract, like identity type questions. They're not actually that hard, but you do have to have those definitions kind of stored away in your brain and know how to manipulate them. But we've pretty much covered every type of exam question, that in general, and practicing some more past papers on this topic will help you further. But I think we've done a pretty good job at covering most types of questions. Okay, Lebo, if you could put the link to the quiz in the chat. Guys and girls, if there are any remaining questions, I'm happy to answer them now. But for those who are ready for the quiz and can go on and do that, that would be awesome. And it was great teaching you tonight. I hope that probability is less of a mystery than it was when you started the course. I hope that this topic goes well for you in the exams. Katlego, let's go to your question.
Hi again, sir.
Hey.
So I just want to clarify this confusion that I have of independent events.
Okay.
When it comes to the contingency tables.
Okay.
Prove that I'm sure that this event, maybe being male, is dependent or whatnot. Those type of questions.
Okay.
When is it dependent and when is it independent?
Okay. I prefer the terminology either it's independent or not independent. All right. So that's the terminology I would stick to. And when a certain identity holds, right? So let me just go to the bottom here. We always check whether or not this identity holds, but the A and B are just placeholders. Now, in a particular situation, the A may be the same as saying like the probability of being male, or it could be the probability of being female, but it's some event, right? And then the probability of B could be this probability. I think earlier on it was like breaking your arm, right? So that's why I would write breaking your arm. Now, what we need to check to see whether or not these are independent is to check, is this equal to the probability of being male and having a broken arm? I'm just going to put broken arm. So we're trying to check if that equality holds. And the way we do that is we work out a value for the probability of being male. We work out a probability for the probability of having a broken arm, and we multiply them together. And we see if it's the same as the probability of being male and having a broken arm. And so we have to decide if this equivalence holds. If it holds, they're independent. If it doesn't hold, they're not independent.
Oh, okay. Thank you, sir.
Pleasure, man. Pleasure. Okay. Any final questions? So Selwyn, there were some lessons on functions and graphs earlier in the year, so that you can have a look there. I know that also in grade 10 and grade 12, they've also done some revision of functions that might be helpful.